Hey everybody. Today we're making beautiful tables in R using the GT package. There are lots of great ways to add tables to your Quarto or Markdown documents in R, but I found GT to have really great defaults, to be extremely powerful if I need to personalize things, and just to be very flexible overall. I'm going to be working with a set of data in the model data package. It's called scat. Yes, it's about poop. And here in the setup chunk that I've added to my Quarto document, I've already loaded up the GT package as well as tidyverse, which I've used for some of this pre-processing. I'll put my code up on GitHub as usual in case you want to work through all of this, but I'm not going to talk through what I did to actually get this, this dataset scat table 1 that I'm going to be using. It ends up having 3 rows, one for each of 3 species, and then 1, 2, 3, 4, 5, 6 more columns other than species, where I have things like length, diameter, and mass for the various different fecal matters found in these sites where these animal poops were studied. Now, I've had a bit of a journey as I've learned about tables, and I want to give some credit right away to a major landmark for me in that journey was a blog by this individual. I'm going to guess Nick Heigem. I'm sorry, please correct me if you know this person or if you are this person. This is about doing nice tables in LaTeX using the book tabs package, which I learned a number of years ago. And I just want to point out the contrast between these two tables. The one on top, which is considered less best practice, has a lot of vertical lines and just in general more noise. It's considered to be less accessible and less readable in general. By contrast, the one below is taking out the vertical rules entirely in this case, but almost entirely more generally, you'd want them removed, and is even limiting the number of horizontal rules to increase legibility for all of us and to maximize accessibility for those that are particularly concerned about it. So one thing that I like about the GT package is that by default it respects these sort of best practices that you'll find in style guides such as AP or the Chicago Manual of Style if you want to do a deep dive in some of that like I have. Okay, so let's actually get going on this. Let's say a great table. I think GT stands for great, so let's do a great table. And to start, all I really want to do is to take the data set that I have, which is scat table 1, and pipe it into the GT function. And I'll render this in just a second. Actually, let me render it first. Let's just do that to make sure everything's functional and see how it looks over here. And there it is. So the table looks pretty good. We've got some shading so we can tell the rows apart. And it's keeping to some of those practices that I mentioned a moment ago, limiting the horizontal rules and eliminating the vertical rules entirely. Of course, the shading is going to be something that we can control also. Before I do anything else, I'm just going to hit Command-Enter right here because I want to illustrate we can actually pull this table up in the viewer. And so when I do that, you can see the whole table just pops up under my viewer tab, the same place the same way it would as if I were doing a ggplot. I think the GT package in general is attempting to emulate some of the things we get from ggplot with the grammar of graphics and so on. Okay, so I want to go back and just progressively add to this. So again, inspired by ggplot2 and the way we graph functions using the grammar of graphics, GT is asking you to first get your basic table and then sort of go back and refine it by piping the thing that you have into additional arguments. I guess ggplot uses a plus because it kind of predates the popularity of the pipe in R. I think if it were being written today, it would probably have a pipe instead. Okay, so I have a bit of a wish list here. I think the first thing that I'm going to want to do is to fix this column label. In my data set here, when I was doing my group by and summarize, I used a lowercase c for count. Usually when I'm doing data wrangling or whatever, I prefer lowercase. I use snake case and start with lowercase letters. But in this table, everything's capitalized, and I kind of like the fact that the column names are capitalized, with the exception of count. So I'm going to fix that right away. And to change the labels on the columns, you pipe the table you've already got into calls label. There we go. And the syntax here is the name of the column that we have, the actual column in the data set, count, and then a tilde, and then in quotes, the name of the new column, the new column name that you actually want to display. Now this won't actually change the underlying data set, but it will change the way the table is printed out. And so there you can see I've got a capital C in count. This sort of function or model notation here is kind of nice because it allows you to add new things. So for instance, if I wanted to do something to length, which I don't really, I could just do, say, with 3 L's. I don't know. Let's see how that looks. It's going to look bad. So the point is you can change all the column names right at once if you want. Okay, so let's get a nice title on this. I want to change what's known as the table header. Here I can put both a title and, if I like, a subtitle. So when you're adding elements to your GT table like this, the fundamental syntax is tab underscore and then the thing you want to work on. So you can change caption, footnote, header, etc. We'll get to some of these as we go. So I want to change the header element. And there's 2 elements to a GT table header, the title and the subtitle. So let's go ahead and put both of these in. So title, I don't know, how about California Poopies? I'm feeling a little bit silly today, sorry. And then let's do a subtitle. Maybe I should look at the help file for the scat set before I decide on this. Morphometric data on scat. So let's use that. Maybe I'll just even copy and paste this. Yeah, that seems to work okay. All right, and let's go ahead and render so we can see this in the actual rendered HTML document. There you go. I want an S on the word of an S on the end of this word here. You can see I've got my title and my subtitle. Great. Okay, so let's add some source data, right? We've got a citation here, so let's use it. So I'm going to take the table that I've got and I'll pipe it into tab source note. And so let's just start by putting this in, copy and pasted in quotes. See how that looks. It's obviously not going to look ideal just yet. There it is. Okay. So I'd like to add the word source at the beginning, and if I look at the way this is actually written in the help file, wildlife biology is in italics. So first let me put in the word source with a colon, so that'll help. Now I want to get some italics here. Maybe while I'm at it, I'll even boldface the word source. So what I'd like to be able to do is to use some markdown syntax. And one really great thing about the GT package is that it allows you to do that by putting MD and then parenthesis and then the thing you want to put in actual markdown notation or actual markdown. So let's see here. For my source note, let's have source be boldfaced. And then let's have wildlife biology, the name of the journal, be italicized. And I'll render that to see how that looks. Great, so you can see I've got both the boldface and the italics just like I'd like. And you can use this markdown command, the MD command, not just there, but elsewhere in your table, construction as well. So for instance, count could have used markdown. By the way, there is also an HTML command. I won't go into that. In the GT package, interpret input text as HTML formatted text. So if you're good with HTML as opposed to Markdown, right where I put MD, you could put HTML, and that gives you a lot of fine-grained control over how the text actually looks. Okay, so the next thing that I'd like to show you how to do here is how to put a spanner on. So if we look back at this blog, you can see that the columns here are kind of broken into 2 pieces. So tall equals u sub single and tall equals u sub double. This is a really common thing that we need in our tables, where we want to do a little bit of grouping for some of the actual columns. So let's take care of that. The thing we need to do is to pipe into yet another tab thing. So add to my table. And the one that I want is tab spanner. So these horizontal rules that only go through part of the table, those are called spanners. And I need to specify two things for my spanner. I have to say what columns it's going to cover and what the actual label is going to be. So let's actually do that. Let's say I think what I want to do is to label the length, diameter, and mass as maybe physical averages, because these are means. So how about physical averages? I think for brevity, I'll just do this one spanner. I could also put one over the D13C and the D15C. I don't think I'll do that. All right, now what columns do I want? COLUMNS. Well, I have to specify this, and I can use tidy select syntax. So everything that I know from the tidier package can get used here, which is really lovely. I could specify my columns using numbers, names, using a colon for a span, those wonderful helper verbs like includes or starts with. I just want to start with length and go through mass. Okay, so I guess seeing it in the viewer isn't quite good enough, so let's just go ahead and look at it in the actual markdown. And there you go, you can see the one spanner. For this particular data set, it's not necessarily that helpful, but it certainly comes into play plenty often. Okay, so notice here that that species is kind of playing a special role. It's sort of identifying almost like a row name. So that's sometimes something that you want to set off to the side. Now, personally, I kind of like the way this table looks. I like the fact that it does not have any sort of distinguishing thing about a row name, but we can go back and change that. So I think I'll do that. If I want to specify a row name column, that actually goes inside the actual GT function for when I'm setting the basic table that I'm making. And the syntax is row name underscore call, and then you have to say the name of the actual column you want. So in this case, it's species. Species. Render that so you can see it. Maybe you'll see why it's not quite my favorite. So it gave me a vertical rule here that isn't my favorite. It also took out the name of the column, literally treating these as row names in some sort of underlying data set. Now, if you want to put the word species back in, you have to do something a little bit extra. I think I'll do it really quickly just to show it. This one does go in a tab command. It's tab stub head. And then I just have to say what the label is. And so it should be species. See how that looks? Okay, so this is something that might be useful to you. Again, for me personally, it's not my very favorite thing. Now, there's a few things that I kind of want to point at, but that I don't want to go into in depth. And the first is tab footnote. So there's a lot of powerful ways to add footnotes to your table, and I just want to point that tab underscore footnote is something that you would pipe the table that you already have into in order to add a footnote to your table. So for instance, I could put a 1 next to Bobcat, and then down below I would have the number 1 that would then say some things about the Bobcats. I'm just pointing you towards the help file here. I'll go right down to the examples because I think it's helpful here to see that for footnote, you have to say both what the footnote is going to be and where it's going to go. And so the syntax there uses this helper verb cells underscore. There's actually several helper verbs there. Cells body, cells column labels, etc., depending on where you want that footnote to go. The other thing I want to nod my head at without really showing in depth is the format commands. So fmt underscore whatever. So I'll just go down to format for instance, and look at that help file. The idea is that when you have these columns, they're going to be formatted just according to R's default. So, you'll have double precision numbers, for instance, or integers or whatever it might be. But sometimes you might want to actually display them in a bit more of a stylized manner, for instance, with percent signs after everything. So something like format_% is going to let GT know that it should be printing things out actually as percents. And all of these different commands have options that can allow you to customize things like how many decimal places to keep, where to place the percent sign, etc. And if you just look at what the autofill in RStudio does when I type in FMT, you can see there's lots of different options here. For instance, I looked at format %, format Roman, format scientific. All of these might very well be helpful to you. Great. I think what I'm going to do next is to, I'm going to copy and paste this. And I want to get a stylized version. Stylized version. And when I say I want to copy and paste it, I want to do it without this stub. And I've got the tab stub head also out of there. Let me just make sure this is going to work for me. Whenever I do a big change like that, I'm especially careful to hit knit or render afterwards just to make sure I didn't break anything. Okay, so there's the table that I'm working with. I want to point out in this case that I can change sort of the default layout here. Just like with ggplot, there's different themes that you can switch to that are sort of completely different ways of looking at the plot without changing the actual data. It just kind of changes the overall style. Same thing here. And I want to point out opt_stylize. And you'll see that we need style equals and then a number and then color equals. Here data is just coming from what we've already got. So style 1 is the default. So let's do style 2 and see what that looks like. It will look slightly different, but not radically so. There you go. So you can see now I've got this box around. There's a little bit of color involved. The other thing that I can add here is, well, pick a different color. So if I want to do color red, I can do that. Let's see what that looks like. There you go. So you can choose sort of a little bit about your color palette. Now, be aware that you're a bit more limited here. You can't just put in any color that you want. For instance, sometimes I might want to use light blue, for instance, and you can see that RStudio recognizes light blue as a valid color choice. If I were to put that into ggplot, for instance, as a color choice, it would recognize it. But if I try and execute this now, I'm going to get an error. Error in opt_stylize, the color value must be one of 7 specific colors. So we're pretty limited in our choices here, unlike within ggplot. Now, I don't think that's the end of the world. You need a lot less flexibility when you're choosing colors for tables than you do when you're choosing colors for actual data visualization. If you want to get more fine-grained in your control over your table, you can do that. The commands that allow you to do that start with OPT. So I started to pull up a help file with $OPT, and you can see some of the different options that are open to you here. So row striping and so on. I'm not going to go into any of that. If you want to do a really deep dive into manually controlling your styles, I'm afraid this isn't the video for you today. The last thing I want to do is to show how GT handles grouped data. So going back up to my setup chunk, you'll see I made 2 tables. We've been working with scat table 1. I want to look at scat table 2 for a second. And I'll just print that out in my console so you can see it. So here we've got 5 columns and 8 rows. But in particular, it's grouped by species. So here I have 3 different species, bobcat, coyote, and gray fox. And then within each of those, I've got a couple of different observations. So let's see how the GT package handles that. Let's take scat table 2 and just pipe it into GT and see how that looks as it comes out. Okay, so of course none of the styling is there. I didn't copy and paste any of that. I've just got my more basic version of the table. So the values in the group variable, Bobcat, Coyote, and Gray Fox, have each gotten a row of their own, and then the rows in our original data frame have then been split up. So here we have 2 each beneath each of those headings. So compare that to my basic printout. Bobcat, Coyote, Gray Fox, each with 2 of each. Notice what happens if I ungroup this first. So the ungroup command from tidyverse, I think dplyr, is going to strip away the species attribute. And now if I render this, I'm going to get a table that's going to look more or less exactly like that printout that I have here in the console. There you go. You've got Bobcat twice. It's got its own column under species. So that just fundamentally looks different. By the way, we can also let GT know that there are groups on the fly. We don't need to actually insert a group by command if we want to have this kind of table that we had a moment ago. So let me just show you that. What I want is inside of the GT command, I want group name call equals, and then in quotes, the name of the column. So in this case, it's species. As usual, here GT is going to be looking for the name of the column in the actual data set, not some sort of assigned column name that you might have put in elsewhere in a GT pipeline. Okay, so that gets us back to this grouped table where we have Bobcat, Coyote, and Gray Fox each separately, just like we might have wanted.